some more examples for the nomenclature of alkenes. Let's take the first example. How are we going to name this compound? The first thing is to find the longest chain. We need to make sure that the double bond is included in the longest chain. So our longest chain is right here, or it can also be this one. Both are one and the same, right? And which direction are we going to go in for the numbering? Are we going to go from left to right to the top, or in this direction? Okay, if you go in this direction, that puts the double bond in the third position. But if you go from left to right, then it puts the double bond in the second position. Remember, we are not going to pay attention to the substituent, but we are going to pay attention more to the double bond because it's going to act more like a functional group. So the numbering here is going to be like this. Now, since there are totally 5 carbons in here and there is only one double bond, it's going to be called as pentene. And where is the position of this double bond? It's starting at position 2. Therefore, this is going to be 2-pentene. And then leaving the 2-pentene, you also have a methyl group. And this methyl group is present on position 4. Therefore, this is going to be 4-methyl-2-pentene. Make sure to put the hyphen between the number and the word. Let's go on to the next example. Let's find the longest chain first. Our longest chain is here, right? This is our longest chain. So in which direction are we going to do the numbering? Are we going to go from here to here or from here to here? It is going to be from here to the right. So there is a total of 7 carbons and there is only one double bond, and therefore it is going to be heptene. And on heptene is present a methyl group and also a double bond at position 3, right? So there is a double bond at position 3 and there is also a methyl group at position 3, and therefore the name for this molecule is going to be 3-methyl-3-heptene. Let's go on to the next example. In the next example, we have 2 functional groups. We have an ether functional group, right? And we also have an double bond. Now between these two, which one has got higher priority? For this, we are going to use this chart, which is going to give us the priority of the different functional groups. Where is ether present in this chart? Ether is present down at the bottom, okay, and it should be called as alkoxy. And then the alkene is actually going to have higher priority when compared to that of ether. So which means this is the one that's going to be the parent name for this molecule. Okay, let's go back to our problem. So since we have decided that the alkene is going to be the parent name, we need to give the numbering for the alkene group, right? So by default, this double bond is going to be at position 1, right? And we are going to reach closer to the ether group. So there are 4 carbons in this part of the molecule. You have to consider this as an alkene. What would be the name for the alkene which has 4 carbons? It is going to be butane, right? And where is this double bond present? It is present on the first carbon. So it's going to be 1-butane. And leaving that 1-butane, we have an alkoxy group, right? Alkoxy group is just a general term. And if you want to be more specific, right? So we needed to count the number of carbons that this molecule has. So it's going to be 1, 2, 3, 4, 5. There are 5 carbons in the alkoxy group. Therefore, this is going to be pentoxy 1-butane. But where is this pentoxy group connected to the butane? It's present on the 4th carbon of the butane, and therefore this is going to be on the whole called as 4-pentoxy 1-butane. The next molecule has 2 double bonds in it, and therefore the parent name is going to be ending with diene. Now, how many carbons in the longest chain? So our longest chain is going to start from here. This is going to be our carbon 1, and it's going to go in this direction. It can go here, or it can also go here. So either way, it should be right. Right? So let's give the numbering here. This carbon is going to be 1, 2, 3, 4, 5. There are totally 5 carbons. Therefore, this is going to be pentadiene. And on pentadiene is present 2 double bonds and a methyl group. Now, where are the 2 double bonds present? It's present on first carbon, right? And it's present on the 3rd carbon. There's one more double bond present on the 3rd carbon, and therefore this is going to be 1, 3 pentadiene. And then leaving that 1, 3 pentadiene, we also have a methyl group which is at position 4. Therefore, it is going to be 4-methyl 1, 3 pentadiene. Here is a branched alkene. Let's find the longest carbon-carbon chain in this molecule, making sure that the double bond gets the lowest possible number. So which direction are we going to go in? Are we going to go from left to right or from right to left? Here or from here to here? It would make sense to go from left to right. Right? So this is going to be 1, 2, 3, 4, 5, 6, 7, 8. Since it has got 8 carbons, it's going to be octene. And where is the position of the double bond? It's present on the 3rd carbon, so this is going to be 3-octene. And then leaving the 3-octene, we have 2 substituents. One is a methyl group and the other one is an ethyl group. And these are present at one at position 3 and the other one at position 6. We need to make sure that the substituents are listed in alphabetical order. Right? So the ethyl is going to come first. The position of ethyl is 6. So it's going to be 6-ethyl. And then 3-methyl 3-octene. That would be the name for this molecule. Let's go on to the next one. Here in this case, there are 3 things, right? We have 2 substituents and also we have functional groups. Now remember, the halogens are considered as substituents. They are not considered as functional groups, right? So which means we need to give priority for the alkenes. So by default, this carbon is going to be 1 and we need to reach the longest other side of the longest chain. Okay. So 1, 2, 3, 4, 5, 6, 7 carbons. Since it has got 7 carbons, it's going to be heptene. And the double bond is present at position 1, therefore it's going to be 1-heptene. And a chlorine is present on the 4th carbon and a bromine is present on the 5th carbon. Arranging them in alphabetical order, it's going to give us 5-bromo, 4-chloro, 1-heptene. Some more examples. Let's find the longest chain in this molecule. This is our longest chain. The longest chain has got a total of 8 carbons and by default this is going to end with octene. That would be the parent name for this molecule. Now when it comes to the numbering, we need to be very careful which direction are we going to number these carbons. If we go from left to right, that puts the double bond in the 4th position. And if we go from right to left, that also puts the double bond in the 4th position. Now which direction are we going to go in to give the right name for this molecule? Now if you go from right to left, that also puts the methyl group with the lowest possible number. So you want to put the numbering from right to left. Okay, let's complete the name for this molecule. Where is the double bond present? It's actually starting at position 4. So therefore this is going to be 4-octene. And leaving that 4-octene, you have 2 methyl groups. One is at position 5 and the other one is at position 2. So it's going to be 2, 5 dimethyl 4-octene. For this molecule, the longest chain has got a total of 6 carbons and therefore this is going to be ending with hexane. Hexane is going to be the parent name for this molecule. Now what about the numbering? Whether you go from left to right of this longest chain or from right to left, that puts the double bond in the 3rd position. So this carbon moving from left to right, it's 3. And this carbon moving from right to left, it's going to be 3. Right? So the double bond is by default at position 3. But what would be the best name that we can give for this molecule? For that, we have to look into the substituents. We have 2 substituents here. We have a bromine, which is at position 2 when we start counting from left to right. And we have methyl group, which is at position 3. Now between these two, which one are we going to choose? Obviously, we have to choose to go from left to right. That way, both the bromine and as well as the double bond will get the lowest possible number. So this would be the numbering for this molecule. And the double bond is at position 3. And then leaving that, we have a bromine at position 2. And a methyl group at position 4. So therefore, this is going to be 2-bromo, 4-methyl, 3-hexene.